So a pretty common question is to be asked to approximate a sum with an error smaller than some given number. So what you hope for is that your series is alternating, and if you look at this one, n plus 1 will change from even to odd as n changes. So I know that this is an alternating series. If I look at the limit as n approaches infinity of the non-alternating part, 1 over n to the fourth, that definitely goes to 0. It's a decreasing sequence. So I know that this actually converges by alternating series test, which means I can use the alternating series remainder theorem to do this. So what I would do is I would look at how much error they want. A 0.001, my error has to be less than that, and I'll write that as a fraction. So this is 1 over, and it's tenths, hundredths, thousandths. So for alternating series, you watch the magnitude of each term, and if you get a term that is less than 1 over 1,000th, you know you've gone far enough, and in fact you've gone one term too far. But I always go till I get a number less than this just to make sure. So what I'm going to do is actually just start plugging in my n values, evaluate this sequence at each value of n. So if I plug in 1, evaluate at 1, 1 plus 1 is 2, negative 1 squared is 1 over 1 to the fourth. My next term, I would take a 2 and evaluate this at 2. So negative 1 squared is a positive 1, so it's plus 1 over 2 to the fourth. And it does, we start with 1, so it's a 2. When it goes to 2, 2 plus 1 is 3, so that would actually be a negative. And it does alternate, so plus 1 over 3 to the fourth minus 1 over 4 to the fourth plus 1 over 5 to the fourth minus, and you could keep going forever, and you need to know where to stop. So you really do need to check magnitude as you go. So I'm going to just stop right there and check and see how big these fractions are. 1 to the fourth is 1, so this is really just a 1, minus 2 to the fourth is 2 squared, so that is a 1/16, 4 squared is 16. 3 to the fourth is 3 squared, 9 squared, so plus 1 over 81, and you can see that the denominators are getting a lot bigger quickly. 4 to the fourth is 4 squared, 16 squared, so minus 1 over 256. So I'm going to get there very soon. 5 to the fourth is 5 squared, 25 squared, so plus 1 over 625. I'm not there yet. I need to get to a fraction less than this before I know for sure. I look at this, minus 1 over 6 to the fourth is 6 squared, which is 36, and then you square that, and that is actually 1,296, which is a fraction less than 1 over 1,000th. So what I need to do is stop one term below this, before this. So I would estimate the sum with the first 5 terms, because the alternating series remainder, for that we know that the remainder has to be less than the very next term. Well, if my remainder, my error, is less than 1 over 1,296, then it has to be less than 1 over 1,000. So this would be the sum of the first 5 terms would be my approximation that would have an error less than 0.001.